All right, good morning, everyone. Today is the 21st of September, year 2020. Last time we have talked about the idea, the microscopic description of internal energy. And I will write that down once again. And we have a little bit outstanding part on page 10 of your learning package to be covered. Okay, then we will move on, right? So it's good to have some revision of this idea because the idea will be tested and has been tested again and again in the exam and the public exam, so on and so forth. All right, the idea is the internal energy of an object is equals to N times N is number of molecules of the object. Okay, we talk about one object and N should be really large. Okay, if you have learned chemistry, for example, I'm holding a chalk here. The molecules in these pieces of chalk can be, the number of molecules can be as large as 10 to the power 22 or 10 to the power 23. This value, which is really large because each and every molecule is very extremely small, right? So the first term is internal energy is the energy inside the body, the object. And so it is the manifestation, the idea of all the molecules PE and KE, the summation of all of them. Okay, so first term about KE. Okay. Okay, N times average molecular KE, and this term is the total kinetic energy of all its molecules. Plus once again, N is the same of this one. Okay, same, and times molecular PE. Okay, and average molecular KE depends on temperature in the Kelvin scale. Average molecular PE, simply speaking, it depends on spacing of molecules. Okay, the spacing between the molecules, right? So on page 10, this is our revision, and on page 10, we have this part, right? We have two outstanding parts, a table to be filled in. Okay, and I'm going to explain here average molecular kinetic energy, the microscopic point of view depends on KE, kinetic energy, depends on. Okay, now you are asked to put in a microscopic view, microscopic concept, which is related to the molecules. So from the molecules point of view, the larger the speed, the larger the kinetic energy, right? And so the first idea for average molecular Ke from the microscopic point of view is the speed of each molecule. Okay? So the microscopic view here should put in speed or average speed of the molecules. And the macroscopic point of view is T, temperature. So how to distinguish these two concepts, which is microscopic or which one is macroscopic? For any macroscopic idea, you can use one method to distinguish them. For example, you ask yourself this question: can this physical quantity be measured? Can this be observed directly? Okay. If yes, then it is a macroscopic concept. Okay. However, this is not the only way to distinguish them. Okay, but you can use them to help you to understand things. All right. So, 1 or temperature can be measured directly with a thermometer, right? And so this can be observed, can be measured directly, and they should be, this physical quantity is macroscopic. While the speeds of the molecule, the speeds are really, really small. For example, gas molecules, we cannot see them. They are invisible. How can we capture certain gas molecules and measure their speed, which is very, very difficult and cannot be measured directly. For example, the molecules in this chart, they are vibrating up and down, sideways, left and right, and to and fro, right? In 3 dimensions, how can I measure the speed of this vibration? Really difficult. No direct measurement can be made in any advanced laboratory in the world. No one can measure that, okay, directly. And so this is microscopic concept. This concept related to one molecule or molecules or particles and cannot be measured directly. And so they are microscopic concept. 微觀，微觀。The idea is the same, okay? The idea is not very difficult, okay? When the molecule moves, when it has certain speed, right? Then it carries some amount of Ke. However, we cannot measure them directly, okay? Okay, and then the average Pe microscopically is about the average spacing. Okay, between the molecules. And once again, this is very difficult to measure, okay? We can make a rough estimation, for example, but very hard to measure. All right, I have 2 chalks here in my hand. The distance between them, okay, can be measured directly with a ruler. And this distance, the spacing between them is macroscopic because it can be measured directly. However, the molecules inside each chalk, they are closely packed together, and the size is extremely small. How can I measure the spacing? Really difficult, right? And no one can directly measure the spacing between two molecules. Not to mention that they are vibrating, right? They are not stationary. Really difficult. So this concept, average spacing, is microscopic. Okay, cannot be measured directly. But the idea is simple, right? Spacing, the distance between two things, right? Very simple, the idea. But since they are too close together, very hard to measure. And for the average PE, the macroscopic idea is this: we can easy to distinguish them with their physical states, the states of matter. Okay. Which are gas, liquid, and solid. These are macroscopic concepts because by plain trivial observation, you can tell that, okay, this chalk is in this solid state, right? Very simple, very easy to observe. Macroscopic, we can observe. All right, that's it. And the next part is a statement telling you in general the PE in solid state. Okay, the PE in solid state. Okay, you are going to put some symbols in the rectangle boxes. There too, okay? We compare the values. So the first one is this. The PE in solid state is smaller than that the PE in liquid state. And the PE in liquid state is smaller than the PE in the gaseous state. Okay? And microscopically, because molecules, the average spacing of molecules in gaseous state is much larger, while the average spacing in liquid state is medium, and the average spacing in solid state is the smallest. Okay. All right. That's our little revision and some interpretation to finish the notes. Okay, and I hope all of you could understand. And then on page 11, question number 5, we have this one. Okay, the CE questions of year 2005, year 2005. You are asked to distinguish, okay, whether these two statements are true or false separately first, okay? We stopped here in the previous lesson, I guess, if I remembered correctly, okay? The first statement is this: when two objects are in contact, there must be heat transfer from the object with more internal energy to the one with less internal energy. Okay, some of you made a mistake here in the previous lesson, right? This is usual, this is normal, because you have to understand this concept completely, clearly, and after which you can have a clear picture or understanding, okay, to find out the correct answers. Okay, I'm going to explain this CE question 2005, statement 1, okay? Why this is incorrect, this is wrong, right? So I will use the same example in the previous lesson. However, we haven't finished all the discussion, right? And so we think of this. We have an iceberg with n I equals to say 10 to the power 13 molecules. Okay. Okay, and we have a cup of tea. Okay, where we have n of t equals to n to the power 20, for example. Okay, just for example, I haven't do any measurement, just for example, okay? Because the cup of tea, which is, for example, a few 100 grams, but iceberg in the open sea, which is in the measurement of tons, right? Many millions of tons, for example, okay? So the iceberg should have much larger number of molecules than that in the cup of tea, right? However, the cup of tea, which is say at a temperature of 19 degrees, just prepared, or freshly prepared, okay? And the iceberg is at a temperature, say a minus 10 degrees Celsius, all right? So now I'm giving them some numbers, okay? The numbers are not correct, but I just give them some number so that you can do some calculation, okay? To understand the whole picture. And so the average molecular Ke, which is related to temperature, which is 263 K, and which is 363 K. All right, change it into K first. Okay, now, for example, I just use a pretended number to represent the average Ke. Okay. Right？ 同學呢個數字一定係錯㗎，我作嘅，即係方便去比較嘅啫，得唔得啊？咁就每一粒 molecule 咧就1個 joule， 咁其實咧就一定冇咁多嘅，好細嘅其實，因為一粒 molecules 嘅 energy 好少嘅啫，應該咧就係譬如10嘅負19次咁樣啊，或者嗰啲呢啲單位就啱啲，但我哋就唔想咁多數學啦，就 concept 嘅啫，得唔得 ？OK 啊，得唔得？咁呢一個咧，嗰個 average Ke 咧，嗰個 T 咧就大概係10倍啦，當佢10倍先好唔好啊 ？OK， 咁佢多100 K 嘅呢度啊 ，larger than that about 100 K， 可能以後會 prove 㗎啦嚇，咁啊同嗰個 root T 係相關嘅。咁啊，大概當佢大10倍啦，係咪？嚇 ，OK， 啊，得唔得？咁實際上亦都係好細嘅，因為咧 each molecule is extremely small 嘛，係咪？我呢個數字唔係咁嘅嚇，真係會細好多，得唔得？但係唔緊要，我哋計一計先嚇。嗱，咁咧我哋咧喺呢度咧，我哋 skip 個 part of 個 PE 啊，因為咧嗰啲PE 嗰部分咧，我哋當佢唔計先啦嚇，淨係計呢一部分先。 等你有個 picture 嘅啫，得唔得？咁所以呢個 internal energy 咧。acid 味10嘅30乘1係咪 ？OK 呢一邊咧，呢一邊呢一邊咧，10嘅20次係咪？20就乘10，所以咧係10嘅21次。OK 咁所以咧係呢一個咧 total internal energy 大過呢一個大過呢一個得唔得？因為嗰個 number of molecules 咧實在太多啦咁我上一堂用個例子咧就話有國家好多人有10億人，但係佢平均嘅收入咧就1蚊咁樣，咁所以個國民生產總值咧咪10億咯係咪？但有一個國家咧就好少人OK， 咁佢得幾百萬嘅啫，say 500萬咁樣但係咧佢每個國民收入咧佢就有1億喎，係咪你假設咁先啦，誇張啲啦，係咪咁佢sorry佢嗰個500唔係咁多即係佢有500萬就少好多但係咧佢個人均收入咧就多啲，譬如一個1蚊，另一個多過100倍100蚊咁啊，你100乘500萬咧都唔會即係大過1億噶嘛，係咪？得唔得？你自己計一計啲簡單嘅數學。所以咧就係咁我就話 when two objects are in contact, there must be heat transfer from the object with more internal energy to the one with less internal energy。好啦，咁邊一個係有多啲 internal energy 咧？就係呢一個喎，係咪 ？I squared 喎。咁邊個有少啲 internal energy 咧？就係呢個 cup of tea 喎，係咪？係嘛？咁但係 energy 係點樣 transfer 嘅咧 ？energy 點樣 transfer？當嗰個I squared 喺呢度黐住嗰個cup of tea， 個 cup of tea 喺呢度啦heat 係點樣 transfer？heat 係 transfer from higher temperature to lower temperature 嘛，係咪？雖然咧呢度咧就 total 咧就細，但係咧啲 energy 都係呢度走過去嘅喎，即係呢度90度 C 啊嘛，呢度10度 C 啊嘛，係咪？係咪？O 唔 OK OK 嘅咁所以咧 heat transfer 咧係 from hotter object to cooler object 啊嘛 ，colder object 啊嘛，係咪？即係由嗰杯茶就去個冰山嗰度，因為杯茶熱啲啊嘛。咁雖然咧茶嗰個 total energy 咧個 internal energy 係細啲嘅，但係佢都會俾啲 energy 佢嘅，佢都會即係你當捐啲 energy 俾人。呢個明唔明白先？同學有冇問題呢度我記得上一堂咧講即係以前一啲人個人生活啲經歷啦，係咪咁大家你又唔知㗎啦OK， 咁你翻去問一問你啲親朋戚友啦譬如70年代或者80年代初啲香港人係點樣翻鄉下嘅咧？咁樣特別係70年代初期咁樣嗰啲日子或者中後期，總之84年之前啦啲人點樣翻鄉下嘅咧佢帶好多嘢翻去嘅接濟佢哋嘅OK 好，咁就呢個第一個 statement 啦第二個 statement啦，佢話對 internal energy of an object increases with its temperature。第二個 statement 咧就啱嘅第二個 statement 呢個 temperature increase 啦，即係 average molecular Ke increase 啦，呢個 increase 咧即係 total internal energy of the object increase 所以 second statement 咧係啱嘅第一句 statement 係錯嘅即係呢一個第一個 statement 係錯，第二個 statement 係啱，你判別咗呢個就得啦。咁就答完題目㗎啦。好如果同學冇問題咧，我哋就 move on to next section 㗎啦我哋都花咗好多時間喺呢啲 concept。咁如果大家都仲係唔明嘅話咧，咁唔緊要嘅咁你花多啲時間咧就去 即係做多啲溫習啦，或者係 when 嗰個 school resume 咧，你嚟問我啦。個別同學你可能有啲位棘住諗唔通咁樣啦，你自己嚟問我啦。咁 OK 啊？好嘅，咁我哋就去下一個 chapter 㗎啦，即係下一個section 嚇。咁咧就係work done、energy transfer 同埋 power。OK， 就同埋 power。好。好啦，我哋咧第一堂咧就剩翻依家咧就幾分鐘嚇。咁咧我就高呼第一小部分啦，睇下夠唔夠時間啦嚇。OK 嚇。咁其實咧actually 咧咩叫 work 咧 ？work 咧就係 energy transfer 嘅都係heat 咧就係 energy transfer， 但係 work 咧就係 due to 咧一個 force 嘅一個力去俾一啲即係做一啲嘢，然後咧就將個 energy 咧有個 agent 施力嗰個人施力嗰個人個 agent，OK，which provide the force， 咁俾一啲 energy， 即係另一個 object 嘅啦。譬如我而家揸住嗰個now I'm holding the chalk 啦，係咪或者喺呢度啦。咁我就 push 佢 push， 所以用力㗎嘛，係咪？我唔用力，我放手佢就跌啦，係咪？我 push 佢咁佢咪有嗰個PE 啦，sorry 有 KE 啦，係咪？咁所以咧我推佢嘅時候咧，我推佢行推佢行。咁其實咧呢個過程俾咗能量佢㗎，係咪？咁我用一個力咧俾能量佢，咁我自己嘅能量咧就會即係減少一啲嘢。譬如你射籃球咁樣啦，你射3分波，你咪用力推嗰個籃球出去，係咪？推個籃球出去咁當你推個籃球出去嘅時候咧，你用力啦，係咪？咁然後你將啲 energy 咧就俾咗嗰個籃球喎，係嘛？嗰個籃球咧就飛咗出去啦。入唔入咧，我哋唔理啦，係咪？但係嗰個過程咧，我哋叫做 work done work done。咁就 work done 咧，就 energy transfer， 不過咧就 relate to a force。OK， 咁我都做翻少少溫習啦。咁嗰個heat 係咩意思啊？heat咁heat 咧都係 energy transfer due to temperature difference。咁你將兩個 object 唔同溫度擺埋一齊，佢唔會施力俾佢噶嘛，冇力噶嘛，係咪？有力佢哋就會喐啦。你擺埋一齊，佢哋定定咁坐喺度，所以冇力嘅，冇 work done嘅。不過咧有 heat transfer， 因為佢有 temperature difference。OK 好啦，咁無論係邊一種嘅 heat transfer 都好啦，咁我哋都可以定義嗰個 power 嘅。power 嘅 concept 咧就係 rate of heat transfer。咁我哋中三咧都學咗少少嘅OK 首先咧筆記嗰度咧，我哋咧就去搞翻個 work 嗰個單位先，因為 work 咧就係 heat energy transfer， 佢嘅單位自然亦都係 joule 啦。凡係 energy 嘅單位咧energy 啊嘛，係咪 ？energy 嘅單位咧係 joule J 嘅，得唔得？好啦，咁跟住咧，我哋學過呢個 concept 就係 power。個 power 咧，個 power 嘅 concept 咧就係 energy transfer。OK，over time taken， 需要幾多時間去即係傳遞呢個能量咧？咁樣叫 power。OK， OK， 咁我哋中三都學過呢個㗎啦。咁啊 power 嗰個單位咧就咁啦。energy transfer 咧無論係work done 或者 heat 咧，佢 unit 都係 joule 嘅。OK， 個 time taken 咧就係 in second。OK， 所以 power 嘅單位咧我哋叫做 watt。我哋中三學 electricity 嘅時候學咗 ，OK， 佢嘅單位咧就係 watt， 得唔得？咁啊 ，name after the scientist 啦，亞特先生啦 ，watt 係咪？所以我哋咧簡寫咧就叫成咁樣 ，OK。咁呢個我哋簡寫啊，記得我哋咧就學計嗰個 energy 計收幾多錢電費嘅時候咧，我將呢個 rearrange 一下咧，個 energy 咧就等於 P times E。OK 啊，咁呢兩條式咧，呢個咧就個 definition， 但係用起上嚟咧，用呢個比較好啲。咁我建議大家就用下面嗰個啦，因為下面嗰個咧就冇分數，唔使記住邊個有分子啊，邊個分母咁樣咧，係容易啲記嘅，少啲錯誤嘅。咁啊，以後咧用嘅時候咧，就大家用呢一個啦。啊，上面嗰個係 definition，OK，definition，OK。好，咁我哋暫時咧就到呢一度啦。咁我哋跟住下一堂咧會繼續討論嘅。我哋啱啱你都聽到落堂嘅鐘聲啦嚇，咁我哋稍後再見啊。如果有問題咧請你提出喎，好嘛 ？OK， 我哋暫時 say goodbye 先，唔該晒，拜拜。